Everyone has used lookup here.
Yeah.
So I also forgot to use it. So everyone has a mobile with Looker app, right? Fine. So so I have prepared few questions for you all. So let's see how you understand those things, like the topics we discussed last time. Not here. Hello. Okay, so I wish I can remove that. Okay. Okay, this is there. So I prepared some questions for you, and let's see. So this is about the coordinate transformation, and so something similar questions you can expect maybe in exams and in the examination test also, which we do during the exercise for the qualification for your exam. So can you read this graph very well, like the time scales also here? No? Okay. So for the people who are in the classroom, I think you can also join in the Zoom meeting, and you have two desktop for one PC, right? Do you have two desktop for one PC?
Yes.
Yeah, so you can use one desktop for Zoom meeting and then one desktop for your model also. So you can use this both. But anyway, if you want to see in the presentation, then this is your 0.202. This is 0.005, 0.01, 0.03. And this is time 0.04. This value is 100. This is 0. And of course, this value is your, I think it's 50. Yeah. No, Zoom meeting you can join. You got a mail, right? This morning, I sent you an email. Did you get the mail? You cannot log in here? Okay. But you can see the projector. So what are the informations you can get from this image? This is in a DQ plot. So this is your DQ plot. So this is VDQ. And of course, this green one is your VD, and the blue one is your VQ. So what are the informations you can get from here? If I ask you. So I'm basically interested in the transients. So transient means from 1.1 situation to another situation. So what has happened there? What could have happened that your values are changed? So what are the possibilities here? So you have so voltage drop in ABC. Okay. And what's up? And that could be point T equal to 0.02. So there is a step in a voltage, right? Okay, so this is one possibility. Anything else? You just look the graph and just think what can be possible, what is possible. So I thought not to give MCQs, just to make you think. But of course, in exams, you'll have some MCQs. So can I tell, let's say for the part transformation, part transformation, we use angle theta p, which is omega 2 t plus phi. I don't know, we wrote gamma, right? Gamma naught. And let's say we have the system frequency as three-phase system, phase as your omega 1 t plus phi naught. So in this case, you see in DQ frame DC values. So what you can say?
I can say that gamma naught is the same as phi naught.
Gamma naught is equal to phi naught. Why do you say that?
Because VQ is 0.
Because VQ is 0. Correct. So you mean the phase are aligned. Yeah. And what else you can see? What else you can say?
Omega 1 is equal to omega 2.
Okay, now. Yeah. And why do you say this? Because you have DC. Okay. Can you tell me the frequency? What frequency it is? So that's the next question. Can you tell the frequency of three-phase system? No? Is it possible to tell frequency? Yeah, so in DQ frame, you cannot tell frequency if you do not know the part transformation frequency. You should know one frequency. So what you know is omega 1 is equal to omega 2, but you do not know what is omega 1 or omega 2. So if you know one frequency, you know other frequency. But if you do not know anything, you cannot tell anything. So the answer is no. Okay. Okay. So you can join Zoom meeting, because here the projector does not look nice. So in Zoom, at least you can see little things, but not nice. So, but you can join Zoom meeting and see the screen. Okay. So again, here the green color means V alpha. The blue color means your V beta. Sorry, it's alpha. And here green means the same thing, VD, and blue means VQ. And of course, this is your V alpha beta plot. This is your VDQ plot. This is 100. This is 0. This is 0.02 second, and this is 0.04 second. Now you tell me, can you tell me the frequency of system? The three-phase system. Yes, it's the same DQ graph, but now I have given you alpha beta graph. So can you tell me the frequency of system? And how much it is? 50 Hz. How do you know it's 50 Hz? Yeah. So from here to here, it's your time period. And this is equal to 0.02 second. So your frequency can be 1 over t. Let's say this is your t. And this gets 1 over 0.02, and this is your 50 Hertz. And everything else is again the same. What answer you saw in the previous slide, you can also write the same thing. And you can clearly see in the alpha beta plot that the amplitude has jumped. So like the amplitude has reduced, right? What you saw in the DQ, you can also see in the alpha beta frame also. I have a chat. Okay, yeah, it's correct. So now let's go to another question. Again, the same thing. I will write it DQ. Green is your VD, blue is your VQ, And of course, this is again 0.02, 0.04. Yeah, and this is your 100 and this is your 0. Now tell me what has happened. So people in the Zoom meeting can also use their speaker to tell, so that's also fine. So what do you think has happened?
Piece of our transformation angle is changed from 0.02. No, 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 no.
You were close. You so change in gamma, change in gamma naught. So let's write it. Theta p is your omega 2t plus gamma naught, and theta for your system is, let's say, omega 1t plus phi naught. Three phase, and this is your park. So what you said, change in gamma naught, right? Yeah. Anything else? It can also be change in phi naught, right? Can it be also change in phi naught? So what do you have opinion? Can it be also change in phi naught? It can. Why not? Your three-phase grid voltage angle can also jump, right? It's a sine waveform, and it might happen your phase angle has jumped into the three-phase system, and you have the same Clarke transformation angle. Yeah. So this is also possible, or change in both gamma naught and phi naught. Okay. So change in gamma naught and phi naught. So it might happen that both changed, and they changed, and they are not equal. Okay. So now the thing is, if you want to see the graph again, you can find a relationship between gamma naught and phi naught here. Because the interesting thing is the VD and VQ are same. Right? You can see the VD and VQ are overlapping after 0.02 seconds. And you know, in the DQ frame, the FDQ is equal to, let's say we have this positive sequence. Let's assume only positive sequence. So we have it like this: e power j omega 1 minus omega 2 into t plus phi naught minus gamma naught, right? So here omega 1 is equal to omega 2. Why it is? Because we have only DC. We have only DC. Then what would be our expression? So we will have like f cap into e power j phi naught minus gamma naught. And this you can write it like cos phi naught minus gamma naught plus jf plus cap sine gamma naught of phi naught minus gamma naught. And you can see these two are equal. Yeah. So these two are equal means cos phi naught gamma naught is equal to sine phi naught gamma naught. This cancel out. And you can write tan of phi naught minus gamma naught equal to 1. So this, from this you can clearly write that phi naught minus gamma naught is equal to pi over 4. but probably they will not ask you in this detail. But you can do this. So you can see this, the D and Q components are same. So you can just think and tell that, okay, the D and Q components are same. That means there should be angle difference of 45 degree. Yeah, there should be 45-degree angle difference, and you can find the relationship. So there can be either change in phi naught, or can be change in gamma naught, or can be change in both, so that their difference is pi/4. And whatever we discussed, yeah, so we have DC, and then, so in this case, phi naught or gamma naughts are not the same, as we saw in the last time. In the last presentation, we saw they were same, but now they are not the same. And we do not have change in amplitude. If you see, there is no change in amplitude here. You can find the magnitude, so it's not very visible what it is, but of course you will see some in some x value, y value here. And if you just find the magnitude, how do you know to find the magnitude? You know how to find magnitude. So if you want to find VDQ magnitude, so that is equal to VD square plus VQ square and under root. If you find the VDQ magnitude for case for the time before 0.02 and after 0.02, you will find the same. So there is no magnitude difference. Okay, so this is an example for phase jump. And what was the previous example? So this is for your amplitude jump. So it might happen you have phase jump and amplitude jump in your three-phase system. Okay, possible.
Sorry.
Yeah.
This phase jump, it can be by the PPL, or what would be the reason?
Can be many things. Let's say you have a fault in your three-phase system, and then that does something to the phase. You may have some disturbance in the PLL, or let's say you have, let's say, some disturbance in the PLL, or that could also lead a phase jump. But in any case, if we see something like this, for sure there is a phase jump. And then, of course, if you do have a closed loop control, you will have again, everything goes to the normal. But here we do not do any closed loop control. We are just doing the open loop things. Okay. Okay, cool. This is the same DQ graph. Yeah. And again, as usual, green is your alpha, blue is your beta, and this time is 0.02, and here green is your VD and blue is your VQ. Now you tell me, so we had a question whether we had a phase jump in the alpha beta frame, or in the ABC frame, or for the part transformation angle. Now, which one do you think it is? If you just have to choose two options, within two options, phase jump in VABC, and the second option is phase jump in phi naught, let's say the part transformation angle. The C option is both. I will not say both. Let's say none. So which one do you think? You just have three options. So what do you think should be the answer? So phase jump in A, you said yes. And who said B? B. Okay, so in Zoom meeting, what do you think? Is it A or B? I would like to hear. Okay, there is some chat. It's B. Okay, so whoever thought it's B, they are wrong. It's A. You can clearly see in the ABC graph why there is alpha beta graph. So if you have jump, you can clearly see here the phase has jumped, right? You can, I have not given an option where I told there is a both jump. So it's either jump in ABC or it's jump in the Park transformation angle. And you can see here clearly, why it does not write, okay. You can clearly see here, there something has happened to ABC voltage. And you can see the magnitude remains the same. So I can draw a line like this. Magnitude remains the same, but here the something has happened to the phase. So magnitude remains same, phase the frequency remains same. Okay, so here you have magnitude same, frequency same, but there is a phase jump. Okay, if you see this not doing anything, if you just see this the same thing continuing like this, then you can tell there is a phase jump in your Park transformation angle. I mean, let's see, yeah, if you see something like this, then you can be confident that there is no phase jump in ABC. So there should be phase jump in DQ frame, DQ Park transformation angle. Okay. The next question. So this is your VDQ plot, VD plot. Again, green is your VD. Blue is your VQ. This is 100. This is 0. This is minus 100. This is 0.02. This is 0.04. Now you tell me what has happened. What do you think could have happened? And of course, this is also 100. This is minus 100. So let's divide in two parts. Okay, yeah, you were saying something. Nothing. So let's divide in two parts. The first half, what do you see? It's a DC. So there is one chat. Omega 1 is no longer equal to omega 2 after this thing. Yeah, true. Yes, that's true. So in this half, oops. In this term, we have omega 1 equal to omega 2 because it's only DC. And in this in this part, what we have omega 1 is not equal to omega 2 because it has only AC. If you see, there is no zero sequence component. Yeah, there is no offset in this DQ. So there is no, I would say there's no positive sequence in phase with the Park transformation angle. Yeah, so that's true. So what has happened, your omega naught is not equal to omega 2. So that's a one thing for sure. So it might have happened that your three-phase system frequency changed, or your Park transformation angle frequency changed. So there can be two possibilities. So the first possibility is omega 1 changed and omega 2 constant. The second possibility, omega 1 is constant and omega 2 is changed. Or both changed. Yeah, you're saying something. What is what? Omega 1 is three-phase frequency. Yeah. Park transformation frequency. Yeah. So this is your frequency jump. So you should never think something ideal, For exams, anything can be done. And of course, you can do all the analysis which we did before. Okay, so feel free to read these things. Now, as usual, I gave you alpha beta plot again. So this is your alpha, the green one, the blue one is your beta. Here the green one is VD, the blue one is your VQ. This is 100. It's the same DQ graph, okay? This is 100, this is minus 100, and yeah, this is 0.02, 0.04, this is 0. Now you tell me, we came to know that from the last slide that omega 1 is not equal to omega 2. Now you tell me which case it is. We had three options, right? So we had three options, omega 1 constant. I don't know if I wrote omega 1 constant. No, omega 1 changed and omega 2 constant, omega 1 constant and omega 2 changed, and your omega 1 and omega 2 changed. And let's say none. So which option do you think is correct? Okay, B. People think it's B. And in Zoom, what do they think? So they also think it's B. Okay. So this time I think everyone is correct. So of course it's B. Because you can see from ABC, the alpha beta graph, there's nothing has happened to frequency. Okay. But if there is a change in this frequency, you can clearly see there will be many time periods, like that. There will be many peaks, I would say, in the small time, in this time. I think you know how to read the frequency. Okay. Which harmonics in ABC frame? So this is your DQ plot. Again, green one is your D. The blue one is your VQ. This DC value is 100 and 0. This is 0.02, 0.005, 0.01, 0.015, 0.025, and so on. Now you tell me which frequency is present in ABC frame. So I'll give you some assumptions. So theta p is your omega 2 t plus gamma naught, and theta is, so that will be combination. So I cannot write anything there. So I can say you omega 2 is equal to 50 hertz. Like it's not, let's say f2 is 50 hertz, not omega 2. So now you tell me which frequency is there. So first of all, how do you say it's fifth harmonics? You're seeing the peaks. And how many?
Like in, for example, in 0.02, how many peers are there?
Yeah, and how many you found? You found 5. So we have 1, 2, 3, 4, 5, 6. Now this is already included, in the first peak. So you cannot tell this as a 7. It's 6 peaks. So what do you think now? Yeah. So negative sequence, fifth harmonic. Okay. Anything else? And positive sequence, which frequency? 7th frequency, 7th harmonic. Okay. So first of all, you should see number of peaks. You can do that also, but in this case, I have given you the, yeah, I think I should give one frequency for sure to two things. So yeah, so or else you could just, the time period, you can also compute its frequency. You can also compute which frequency it is. And you can clearly see it has, the frequency is, I think it's not easy. I have to give some number there, but I think this way it's easier. So let it keep this way. But you can find the frequency, and you know which frequency component it is there. And then we learned in the lecture, or not in the lecture, in the exercise, that how you can compute frequency in positive sequence in ABC and negative sequence. Okay, cool. Now I give you this graph. It's the same DQ graph. The green one is V alpha, the blue one is V beta. And here again, we have VD as green. And V blue is your VQ. This is 100. This is 0.02. This is 0.04. And of course, I would mention that your omega 1, omega 2, I would say omega 1 positive, the fundamental, I would say. So let's say omega 1, 1. That would be crazy. Okay, so let me put the same thing. Omega 2 is your 50 hertz. Okay, and you have 50 hertz positive sequence. So omega 1 has 50 hertz positive. Or not omega 1, ABC has 50 hertz positive sequence component plus some harmonics. I would say not harmonics, I would say one harmonic. It has only one harmonic. You should find which harmonic it is. What do you think? So until this is one period. So how many peaks you see in the alpha beta now? Alpha beta. You see 7. You see 1, 2, 3, 4, 5, 6, 7. So it has 7 peaks in one time period. So which which harmonics do you think it is? Yeah, nice guess. So it's 7th harmonics. And which sequence? It is, of course, positive sequence. Because 7th harmonic is our positive sequence. So you might have been wondering, in the alpha beta frame, we just see 6 peaks. In alpha beta graph, we just see 6 peaks for 7th harmonics, and for 5th harmonics also we see the 5th. For negative sequence we see the 6 peaks. But why do we see 7 peaks in the alpha beta graph in the time with respect to the time graph? So you have to.
Both are positive. Omega 1 and omega 2. Like they both are the positive sequence. Like omega 1 minus.
Yeah, so this graph is with respect to time. So with respect to time, there is no relative thing here. Okay, so we do not do any. So it is with respect to time, and if you see, if it's a 7th order harmonics, then it will go, negative 7 times in one fundamental with respect to time. Can you imagine? So if it's a negative, if it's whatever frequency it is, whether it is negative or positive, if it's a 7th order harmonic, it will have 7 peaks in one fundamental period. It will have 7 positive peaks, it will have 7 negative peaks. So if it has 7 negative peaks, then and positive peaks, so for sure you would see also 7 positive and negative peaks in the alpha beta frame also in the time domain. So I'm talking about in time domain. You can do little exercise on this. I'm just giving you some hints, and you can do that. So in time domain, which if you see number of frequencies, if you see the number of peaks, then you should have that harmonics. Don't do any plus minus there. But in DQ frame, you have to think relative way, because there you do the part transformation, and then there is a frequency shift also of things. Which harmonics in ABC? Is this the same graph? Oh, my mistake. I have two graphs the same way. So it's the same graph. So keep it. I would like to show you one graph. Okay, so this is the graph, and I do not want any amplitude jump. I would keep this 20, then fifth order harmonics. So I use the same Simulink model to get all the questions. So you can also try those things. So this is your seventh order, fifth order harmonics. Okay, I will take the screenshot of this. Okay, so here I would name something like this. So this is your V alpha, this is your V beta, this is VD, this is VQ. And this is your time period. Now you should tell me which harmonics is there. Which harmonics do you think it's there? The fifth harmonic. Yeah, because you see one peak, 2, 3, 4, 5. So it has 5 peaks. And of course it is negative sequence, but probably you cannot judge from here whether it is negative or positive. Or maybe you can, I don't think so, because they also go like similar fashion. It's just the peaks are the number of peaks are different. So this is your fifth harmonic. And of course negative sequence. But I would just say fifth harmonics. I would not like to comment on positive or negative here. But we have fifth negative sequence, so let's write it this way. Okay. Mm-hmm. The fifth order harmonics.
No, in the fundamental Like in,
You can have positive and negative. You mean 50 hertz fundamental or 50 hertz?
but in the harmonics, like fifth harmonic can will always be the negative one.
So the thing is, it's a three-phase system. It's a three-phase system, and they are. So I was also confused with that question, but I asked my supervisors. So that I had asked before the lecture itself, like before second lecture. So the thing is, if you see the Fourier transform of the square wave, okay, like you have the square wave signals. So what you would see that. So I can show you also. Wait. So let's say of square waveform. So if you see here, what happens is your frequency, um, your frequency and the phase actually also multiplies. So if you have some harmonics, this is your K means your harmonics, I guess. And here what happens is your whole phase and frequency multiplies. You cannot see any phase here because there is no phase difference here. But if there is a phase also, so phase also multiplies. So this way, if you see, maybe we can see Taylor series. They are all are some fundamentals. It's in German. Okay. Yeah. So here also you can see for the higher order harmonics, you multiply with the 5 times, but there you also multiply with the phase. So also phase are multiplied. Initial phase are multiplies. So it multiplies with the whole angle, the 5 times the whole angle, and that makes it negative sequence. And we also learned, so that is what we have tried also to show you. So we try to show you that yeah, so we here try to show you this h factor multiplied with the whole angle. Yeah, and that is how it makes negative sequence. So this is what I know, and I think it answers your questions, but this is mostly for electrical things. But in case let's say, I don't know due to what reason, but let's say for any reason you have fifth order positive sequence, let's say mathematically it's possible, then you can expect some different frequency of that in the DQ frame. Okay, different number of peaks in DQ frame. So that then it will become like 4 number of peaks for DQ frame. Okay, so you can do those calculations. Okay, so let's move forward. Which frequency do you think it is? Like which harmonic, sorry. Which harmonics in ABC frame? This is your V alpha. Oops. This is your V alpha, this is your V beta. It is fifth harmonic. And of course it is negative sequence. What about this? This is your seventh harmonic. And it is a positive sequence. So in this case, if you see the number of peaks are 6 for both. 6 peak. And here also you have 1, 2, 3, 4, 5, 6. 6 peaks. So if something goes like this, then it's a negative sequence. And if it goes like this, then you can think it as positive sequence. So that's just a one trick to remember. and which harmonics it is you can compute from this peak. Okay, and it's the same number of peaks which you see in the DQ frame. Okay, so as we mentioned in the first lecture, first exercise, that we will have the 4 exams, and then the next exam is going to be the 4 exams, and then you have to pass 3 of them to qualify for the exam. And something similar questions you can expect in this exam, which is going to be in the next exercise. Okay, so the next exercise, and whoever is in Zoom meeting, please listen carefully. So so whoever is in Germany, so one moment, I will write it here. So I will write like a venue. So student in Germany, basically I mean Rostock. So let's write Rostock. Should be present physically. So there's no possibility for them to give the exam online. And students who are due to visa issues, they are not in Germany. So I would say abroad. Yeah. So for them, we will have like an oral exam. So we will not give them MCQs because there is a lot of possibilities they can cheat. So we try not to give them MCQs. So we will do the oral exam for them, but you can expect the same questions or also similar questions in the oral exam. Okay. And I think we have just 2 persons who have not got the visa, right? Is this right? So I need some answer from the Zoom meeting. Okay, in the Zoom meeting, is there anyone who is abroad? Yes, and how many are there? So I know you, the Musa is there, and then Pavitra is no idea who. Okay, so I also heard there are 2 people, so I think there are just 2 people. So for them, there will be oral examinations, and these are just few minutes. Like let's say, uh, so so the written exam would be like MCQs. So you will have some questions, you have some MCQs, and it will be on coordinate transformation, and you have to just tick those things, or maybe you, if you have something to draw, you have to draw it. But for the oral exam, it is going to be the same length, I would say, maybe 10 minutes or something. So you'll have 10 minutes to answer the questions in the paper, also MCQs, and here also maybe we do the exam for 7 to 10 minutes. Okay, so that would be oral exam, and this will be taken by my supervisor, which is Christian Neumann, Mr. Christian Neumann. So he will be taking the oral exam. Okay, so I'm not going to take oral exam. I will be in the classroom taking the physical exams. Okay, so I would like every student, like if someone is absent, then please inform them also regarding this exam because it's important. And if you miss this exam, then for sure you have just 3 exams to be qualified, and you have to pass them all. Or else, if you are not healthy, then you should have some valid certificates. So this is about the revision and the next exam. Now let's go to the next part. So I would ask you to do one more thing. So everyone, please open your MATLAB model, which we created in the last meeting, and implement the inverse Clarke and inverse Park transformation. We did Clarke and Park transformation, right? Please do inverse Park and inverse Clarke also. So I will give you the equations. So let's do first the inverse Park transformation. So which is this one. So this is our inverse Park transformation. So let's do this first. So I have already opened my MATLAB model. So So you can open the model and then do the inverse part. So I basically copy this one. So VD into cos, PQ into minus. So you can keep on doing, and then if you have questions, then you can ask the questions. So let's have a tool. And if you have done this, then you can basically connect this like here, the VDQ, then the theta is the same theta. And you would like to compare this with your alpha beta, right? So you can basically connect this one. And with this alpha beta. So if your transformation is correct, you should see the same answer for both. Yeah, so I can see the same answer. So it's done. Yeah, and always change the label, Yeah, like this one, and then input also, so that it's more clear. Yeah, and change the labels also, This is for DQ. Did you make the model already?
No, I am using yours because
Yeah, that's okay, but make this now. So this is for DQ0 to alpha beta. So inverse Clarke transformation. So people in Zoom meeting, are they able to make it? If you have questions, raise. Maybe you can add comments or speak up. So always feel free to ask questions.
So how can we like practice in the So I need to.
So you can basically copy this, copy, Control C and paste. Oh, you want to right click and drag
Okay, right.
and leave it. Yeah. Then you can basically use it. So this is inverse part. Is it done? You can make this as an input, this angle.
Which one?
This value, as you can keep it as the input. You can see I have made this as the input, because then if you do like this, you make some changes in that outside angle for Park transformation, then it's different. So they should be the same. So remember, for Park transformation and inverse Park transformation, you should use the same angle. No, wait, close this. What you have done? You have this VD. Okay, open this. Okay, fine. So this is correct, right?
Yeah.
Yeah. Then.
Okay.
You should give it this one. Yeah. Now run. So, and you compare this with the actual V alpha,
Yeah,
alpha beta.
yeah. The first graph.
Yeah, but you do not see the second one. So this is fine. Looks okay. But the second one, the beta is not correct. So just check what is happening with the beta. Oh, you didn't multiply anything.
Yeah.
Yeah, so I think once you multiply, it will be fine. You got the graph?
Yeah, I was doing the other.
Yeah, if you are done with the Park transformation, inverse Park, you can do inverse Clarke. If you feel you are done, then you can do. Okay. You have your. Oh, you do it like that. Okay, that's also fine. Then compare this result with the V alpha beta. So student in Zoom meeting, are they doing or they have done, or you can say yes or no if you're doing or not. Okay. Almost done. Cool. Nice. So now what you if you done with the inverse Park, let's say, then you can do the inverse Clarke. So I would do the parallel inverse Clarke. You have the equations, I guess you can do those things. So I will just copy that. And do you know the matrix for inverse Clarke? I think I didn't give you, but you can check. So this is the matrix which you can use. So we have 1 minus. No, so it should be this. Sorry, that was taken wrong. So this should be for Clarke, inverse Clarke. So the below one is for power invariant version. So you know the Clarke transformation. If you do the inverse, you should get this one. So just the matter with the gain. Okay, so this should be just 1, 3/2, then 1. Yeah. So everyone done with the Clarke transformation, inverse Clarke transformation? Yeah. So here you can find the inverse Clarke transformation matrix. You can implement that also if you are done with the Clarke transformation. Yeah.
How can I see the result? I did the
Okay.
inverse.
So just open that first. Yeah, this is VDQ0 and this is V alpha beta 0. Let's change the name.
Alpha.
Also write 0.
See.
Yeah. And there is one thing you, yeah, can you open this model? Yeah. You never do anything with the 0, right? So make sure you also have 0, because if there is some 0 sequence, then
Yeah.
yeah. No, this thing VDQ0. You're just missing 0.
Yeah.
Yeah.
Okay.
And then here this is not VDQ0, right?
Alpha, yeah. Alpha beta.
Yeah. So you cannot do that. Okay. First change this one. It's always good to have the correct naming so that you don't get confused. And the VDQ0, now you can write. It didn't change because there was already one name. Okay, then go back. You should check this V alpha beta 0 and this V alpha beta 0. This should be the same, right?
Yeah.
Yeah.
Yes.
So just check. Done?
Yeah.
You get the same?
Yeah, 80%, but now I think it should work.
Yeah. So this is your inverse Clarke. Is this inverse Clarke?
Yeah.
And this is your ABC. So you can see them in the same graph also. You can just put them together.
Okay.
How do you do that? Use mux. Just click once and then type. You're done? And to verify them, they're the same.
Yep.
This is ABC, and then
Oh,
yeah,
okay.
if you want to verify them, then you just put them in the same graph.
Yeah.
And how do you do that?
A face is equals to 0.
So I think everyone is.
Like this to see the result.
Yeah, just copy this thing, copy the marks. Yeah. Just take another scope. Just copy the scope. Yeah. So this output.
Okay, one.
No.
Oh.
put this here, connect to one, anyone. Yeah, this
Yeah, I remember.
is, yeah, you should practice.
Yeah.
No. Yeah. And then you should connect this with your V alpha beta. No, 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 no. Here.
Yeah.
You want to see them together, right?
Yeah.
So this marks, so not always right click. You have to do left
Yeah.
click.
Yeah.
If you want to connect things, then you do the left click. So you are always doing right click. That's a problem, I guess. No, no, wait.
Okay.
This is the left click for connecting. So click this and then drag.
Okay.
Just click and drag. You have to click and drag and keep on clicking.
Okay.
Yeah. So keep on clicking.
Okay.
You have to keep on clicking and then drag. Yeah. So everyone done for Park transformation, inverse Park? Cool. Then let's do the inverse Clarke now. So for inverse Clarke, we have to implement this matrix. This is for inverse Clarke. And you can see here also how I did. You see the same?
Something.
Yeah, but you see this, they are the overlapping, right?
Yeah.
So they are fine.
Okay.
Yeah, but this is the labeling, so
Yeah. Yeah.
that label you should change. So now implement this inverse Clarke. Let's not spend much time here. What? It works?
Yeah.
Okay, cool. Yeah, so whenever you want to see some results together, it's always good idea to use Mux. And what's your name?
Andres.
You had sent me an email for exercise, right?
Yeah, yeah, I have changed the version, but I cannot. I have the document here, but I don't know how to send you because I tried with the email, but it doesn't work.
Okay, but you know how to save the previous version, right?
Yeah.
And what you wanted to show me?
You said the last time that we have to implement the positive component, negative component.
Oh, yeah.
Mhm.
Okay, that's nice. That's cool. So it looks more organized. So students in Zoom meeting, you also try this, okay? Why I cannot show this? You don't need to click, you just click, hold, drag. That also works. You don't have to click and wait. Cool. Does it work? Does it? So
here in this Clarke, and
This is not shown.
Yeah.
This is 0. So close this. Are you sure this is VIPC?
yeah,
From where does it come?
oops,
Click on this.
from
Just click on this. It is from the alpha beta. You are not. So and this one comes from ABC. Okay. So you want to see the first one, right? But what's the input for this?
this is the alpha beta. I think.
Yeah. Yeah. So
Here's
you
alpha
wanted
beta.
to check the input, but
Yeah.
we are more interested in output. Okay. So the output is fine.
Yeah.
Click on the green one. Okay, cool. Okay, so done with the Clarke. Both are matching. Just click on this someone. Click it back. Yeah. So you can basically see them. You just open this one, whichever graph it was. Then you know if you want to check, they will overlap, right? So this VA and this would be overlap. Oh, sorry. Yeah, so you can basically make it display and then not display, and then you can check whether they are on the same graph or not. Okay, so many students have already done. So in Zoom meeting also students are able to do it. So almost everyone has done in the classroom. Done with both, cool. So now if you are done with both, then so for sure if you do inverse Park transformation, then your output should exactly match with the V alpha beta, which you get from the Clarke transformation. And then for inverse Clarke transformation, the output should match with your the actual VABC system. And I try to run, and you can see that for me, the A and the ABC graph, which is below, is matching. So this, I would use another scope. I don't want to change the labels here, so. Yeah, so here you can see the results. Okay. So this is about the transformation stuff. Now let's have a lunch break. Okay. So let's have a lunch break now, and we will meet in 45 minutes. So that would be like 1:15. Okay, or let's say 1:10. So try to be here by 1:10. If everyone is here by 1:10, we will start. Otherwise we will wait by maximum 1:10, 1:15. Okay, so see you all soon.